Okay, so I hope till this point you people are able to understand what is our problem statement. So just if anyone is having any doubt, you can actually ask meanwhile, no problem. Okay, so now I am going to show you all the steps. How are we going to create that type of a model? Right. So let me just show this thing. So I am sharing one link in the chat box. Those who are not able to join here, you people can join from that link. So I send the link to everyone. Please check it, and those who want to join there, you can join. Now, let me go to the data set again. I hope everyone is able to understand the data. So, chance of admission is going to be our target point, right? So, I am not going to go into the theory part actually because otherwise it will take a lot of time. So, right now, what I will do is I will show you how are we going to create a model which is going to give us this particular output, this particular prediction, chance of admission of the student. Given that, for example, someone out of 340 marks, someone has got 311 marks. In TOEFL, out of 120, someone has got 100 marks, and so on. Given all these features, what will be the chance of that student to get the admission? So you can see the chance of the first student is 92%, second 76%, and so on. So we need to train our model based on all these things, right? So I will directly go, and first of all, I will show you how are we going to create that particular model here. Let me go, let me show you. See, these are the steps, right? Now see in this and yes, once again, what I will do is once we are done with the session, you people will be getting this particular file. Okay, in my case I am using Jupyter. Actually, you need to open this particular file in Jupyter. These are my notes in which I explain each and everything about linear regression and machine learning, mathematics behind that, and the concept behind that, and the code also. So in this file, you will be getting everything, whatever is required. So I am not going to discuss this particular theory part. What I am going to do is I am directly going to the implementation. Okay, just try to understand. I am directly going to the implementation. But as I told you, everything is already explained here. But as I want to directly show you implementation, so let me move to that particular point. I hope everyone is able to understand the problem statement. Let me show you how are you going to create a model based on that problem statement. Right? And how are you going to handle missing data? Now see, what I'm going to do here is I am going to make use of two tools here. One is nothing but I am going to make use of Jupyter, and whatever you are able to see, it is Jupyter. And one IDE I am going to make use of later on, which is going to be PyCharm. Okay, once we are done with the model, and once we need to deploy our model onto cloud, I will show you PyCharm, how to run it onto PyCharm, how to run your model onto PyCharm, and then deploy. So I am using Anaconda's Jupyter for your kind information, all of you. I am using Anaconda Jupyter, and I will be using PyCharm IDE. These are the two tools I am using. Let's start with the development or implementation of the model to create or to solve that particular problem statement, right? Which problem statement? This one, where we need to predict the chance of a admission of a student, right? Now, first step. First step, as usual, is import all the necessary packages, right? So I'm expecting that you people might be aware about pandas. So I'm importing pandas package, numpy package, and there is something called a standard scaler. So standard scaler we this particular package we import generally just to standardize our data, so that each and every feature, each and every column should have equal weightage. Okay, you people do not worry about these things right now. If you are not aware about that, don't worry about these things. Okay, just try to concentrate here. I am going to make use of linear regression algorithm. So linear regression is what now you might be knowing. Linear regression makes use of line of base fit, and that is nothing but equation of a straight line for linear regression is y is equal to mx plus c, or we write it down as y is equal to d0 plus d1x, where this m is the slope and c is the y intercept. right? So either you write it down like this or like this is one and the same thing. So this is the equation we make use of, and you might be knowing line of base fit is nothing but, if your data set is like this, line of base fit always passes through base area. Now what do you mean by this? That means the distance between this one, that is original data, and the line of base fit should be as minimum as possible. This distance should be as minimum as possible, then that line is called as line of base fit. So that is also actually shown in the implementation here. So linear regression is going to take care for that. For implementation purpose, our job is what? Our job is just to make use of this. Just call this method and use that. Whatever linear regression, whatever the work of linear regression is, it is going to do that, right? So that's why I'm telling you that even if you are not aware about all these things, don't worry. You should know this one, linear regression, okay? Which for which theory part I did not discuss. As I told you, for implementation only, it is going to take complete 1 hour. That's why I'm just trying to concentrate on implementation only. So here I have done nothing. I just just imported linear regression. And later on we are going to split our data into training and testing, so that's why I'm importing this particular package, train test split. And for plotting the graphs, I'm going to make use of matplotlib and seaborn. That's why I'm going to make use of this matplotlib and seaborn package, right? After that, whatever you are able to see, it's simple Python function which is going to help you to calculate one metric, and that is called as adjacent r square, right? This is nothing but one metric to check how your model has actually performed. So it is totally based on the formula which is given in these notes, right? So it's accuracy, I can say. There is something called as R square accuracy, and there is something called as adjusted R square accuracy. So as there are some limitations to R square accuracy, so see, for example, once you are done with developing, or once you are done with your model, right? Once you are done with the model, suppose R square statistics of your model is 95. That means the accuracy of your model is 95%. But one needs to check something called as adjusted R square statistics also, because there are some limitations to R square statistics, and that's why one needs to make use of these two. So whatever you are able to see, this is nothing but adjusted R square statistics, or a metric, you can say. In a short, I can tell you that it is going to help you to know how your model has actually performed. Okay, moving forward. Now I am going to go and I am going to import the data set. Which data set? Admission underscore prediction dot csv. How I am going to import it? So I am trying to import it with the help of a package called as pandas, which I have already imported. So admission underscore prediction dot csv. Now how it is able to understand that this is the name of the file? Because I am already in such a directory where that file resides. See this particular file, admission underscore prediction dot csv. This particular file, at whatever the location this file is residing, my current working directory is the same location. That's why I can write down directly. So this is nothing but I'm just trying to import that particular file in this particular data variable. So this data is going to be a data frame. Data.head, now it is going to show you first 5 records by default. You can check. See, everything is imported. GRE score, TOEFL score, university rating, SOP, LOR, CGPA, and everything. So in data variable now we have everything, right? It is just fetching the data. Now data frame name, that is data dot describe. This is nothing but a method which is by default available in Python, which is going to help you to know all these statistics. Now what are all these things? So you can check. This is nothing but serial number column, GRE score column, TOEFL score, and all this whatever is available in our data set, everything is visible here. Now what are all these things? Count. How many number of records are there in serial number column? How many number of records or observations or rows are there in GRE score column, and so on. Now here you can check. Earlier I showed you that there are 500 number of records, but in GRE score there are 485. Why is it so? Because I have already shown you in our original data set, right? So someone is asking me, suppose we are not in your current directory, then how to access that particular file? So if you are not in your current directory, sir, what you need to do is you need to give the absolute path, complete path. C, then suppose Yogesh folder, then suppose directory, and so on. So that I don't need to give here. So you need to give absolute path. Whatever I am giving here, this is called as relative path. Okay, is it clear, sir? I hope. If you are not in the same directory, you need to give the absolute path. I hope it's clear. Okay. Moving forward. So the point to note down here is this describe command has given us very good information. If you can check, as total number of records are 500, but for GRA it is showing me 485. TOEFL 490. University rating 485. That means there are some missing values in my data set, and that's what I'm going to remove now. So how to remove the missing values? That is called as imputation. Removing the missing values, that is called as imputation. How to do that? So university rating, TOEFL score, and GRE score. There are some missing values in these columns. That's what we have noticed from describe command, right? So I will be unmuting you at the end, sir. Okay, those who are asking me to unmute, I will be unmuting you people at the end. Don't worry, I will give you a chance to ask questions. Now see, what am I doing is university rating is a categorical data. So for replacing the missing values in categorical data, we use mode. What is mode? Mode is nothing but the frequency, most repeated value. So I'm just trying to replace wherever there is any value or missing value in my data set. I'm just trying to replace that missing value with the mode of that particular column. And for TOEFL score and GRE score, we are replacing the missing values with mean. Mean is nothing but the average. And now if I go and if I describe, and you can see 500, 500, 500, 500. That means missing values are they are actually removed or they are handled correctly now. So you can see the count, because why we were getting the count less than 500 earlier, because there were missing values in GRE score and university rating and other columns, because by default count function ignores missing values. That's why we were getting less number of records than 500. After that, what am I doing here? So in data, I am storing all the columns except serial number. That means I am dropping serial number. Why? Because we know that serial number is not going to contribute to the output column, that is chance of admission, right? So that's why I'm just removing that. After that, I'm doing what? I'm just trying to see the distribution of the data. How? So it is with the help of distribution plot. From where I got it? I got it from the Seaborn package. SNS is nothing but the Seaborn package. So why am I trying to check for the distribution of the data? Because the basic need for any machine learning algorithm is that your data, first of all, should be in numeric format. That is one thing. Another thing is your data should be normally distributed. Now, what do you mean by normal distribution? So, normal distribution generally looks like this. This is called as normal distribution. This is a bell-shaped curve. If the distribution of your data is something like this is not normal distribution. If distribution of your data is something like this is not, maybe I can, or let me just clear it. If the distribution of your data, maybe it is something like this, it is not normal distribution. This is called as normal distribution, right? And if it is like this, and if it is zero, this is called as standard normal distribution, where mean, that is mu is 0 and standard deviation is 1. Okay, so that's why I'm trying to check the distribution of my data. For each and every column, I'm trying to check the distribution. And if I find out that the distribution is not normal, and that is nothing but there is some skewness in the data, then I'm going to remove that. What is skewness? So maybe for example, if this is called as skewness, this is called as skewness. So this is positive skewness. If it is on this side, this is called as negative skewness. For example, here negative skewness or left skewed data. I am talking about skewness. Okay. So your data should be normally distributed. That's why I am trying to check the distribution of the data. So you can see in our case, with the help of distribution of data, the distribution looks decent enough and there doesn't seem to be any skewness, and we can go and we can continue. Always remember that's a basic requirement for applying any machine learning algorithm. After that, what am I doing is, as I told you, chance of admission is our output column. So I am assigning that particular value to y variable, and all the other columns from data, I am assigning it to x. That means y is our output and x is our input. After that, what? After that, I am trying to check the relationship between input and output variable with the help of scatter plot. Now, you can see here, we are trying to compare our output column with all the other columns. So, chance of admission column, relationship with GRE score. Chance of admission column, relationship with TOEFL score. Chance of admission column, relationship with university rating, and so on. So more or less you can see that the relationship is in the linear fashion, right? And that is one thing that we can go and we can make use of linear regression, right? So you can see here also. Okay, that's what we are done. Standard scalar, I already told you. Standard scalar is the package which we already imported. It is used for what? It is used to standardize your data. Why? Because as I told you, GRE score is out of 340, TOEFL score is out of 120, university rating is out on the scale of 5, statement of purpose 5. So see, there is a lot of differences between all these values, right? So it should not happen that your model is going to give a lot of importance to this one as compared to these values. That's why what standard scaler is going to do is standard scaler is going to scale down all the values to the nearby scale or same scale. For example, maybe go on taking the square root of all the values again and again till what? Till all the values are on the same scale or the difference between them is very negligible, so that each and every column, each and every feature should be given equal weightage. If each and every feature is not given equal weightage, what will happen? Your model is going to become overfitted model. What do you mean by overfitted model? The model which will give you good accuracy at the time of training but very less accuracy at the time of testing. That type of a model is called as overfitted model. Okay, so that's what we do not want, and that's why we are just trying to standardize our data. So what data? What is our data? X. Our input data is assigned to X variable, and I'm just trying to do what? I'm calling a standard scalar method. I'm creating an object of that, and scalar dot fit underscore transform of X. So whatever is the scale data now, I'm storing it into this particular variable. Okay, and after that, I'm trying to make use of something called as VIF, variance inflation factor. Now, what do you mean by this? VIF, for your knowledge, it can be used. VIF, variance inflation factor, it is used to know whether there is something called as multi-collinearity present in your data set or not. What do you mean by multi-collinearity? In a brief, it means that one independent column, that is one input column, is dependent on another input column. See, we have input columns and we have output column, right? If output column is dependent on input column, that is okay. But if one input column is dependent on another input column, that is called as multi-collinearity, and multi-collinearity should not be present in your data set. If it is there, and if you are trying to train your model with the help of that particular data set where there is a multi-collinearity, in that case also your model is going to become overfitted model. That is what? That is while training it will give good accuracy. For example, while training it will give you 95% of accuracy, but while testing it will give you 75% of accuracy, or maybe below that. That is called as overfitted model. So how to check whether your data is having multi-collinearity or not? It is with the help of variance inflation factor. If the value of variance inflation factor for a particular column is greater than 5, that means there is multi-collinearity present in the data set, right? So that's why we are actually trying to do that. So that's why I've imported this particular package, and I've created a data frame which is going to give me VIF value for each and every column. So VIF value for GRE is 4 point something. For TOEFL, VIF value is 3.17. So everywhere you can look at, in our case, there is no VIF value which is greater than 5. See, in this case, if there would have been some column where the VIF value is greater than 5, in that case, what one could have done is, one could have actually remove that particular column where there is a multi-collinearity, or one could have actually combined that particular column with another column, and one needs to come up with new column in that case if there is a multi-collinearity. See, again, if there is a multi-collinearity present in the data set, there are different ways to remove the multi-collinearity. One of the best ways to remove multi-collinearity is, you might have heard about one of the famous algorithm that's called as PCA, Principal Component Analysis. Now, what PCA does is, PCA actually helps you to remove multi-collinearity. Again, PCA itself is another part actually, that's another different algorithm, but generally we make use of principal component analysis as a pre-processing algorithm. But in our case, you can see there is no VIF value which is greater than 5, and that's why we are good to go. After that, this is nothing but what? This is, I am trying to split my data into training and testing. So test side is 25%. That means 75% of the data is training data. So we were having 500 number of rows. So 75% of 500 is for training, and remaining 25% is for testing. Okay, and you might be knowing that that data will be divided randomly. Okay, so this is nothing but dividing your data into training and testing. Once that is done, if once your data is divided into training and testing, now it's time to call linear regression method, create an object of that, and this is the line which is going to actually train the model. On the basis of what? On the basis of training data. X is nothing but input, Y is nothing but the output, train is nothing but the training data. And finally, I am going to store my model with this name, finalize underscore model dot pickle. Pickle is actually a package which helps you to store your model. You can take it like the example of executable file in case of Windows. So something like that. So what I am doing is whatever the model I have created, right? I want to store that model with the help of this particular name. So I am creating a file with file name. File name is nothing but what? This one. So I am opening a file in write and binary mode. That is, binary is nothing but executable mode, and I'm just dumping that this particular thing into this particular file name. And what is file name? That is this one. So that's how we create the model. And if I want to go and if I want to check my model, so here I am passing the input manually. So you can check this 300 is out of 340 GRE score. This is what? This is nothing but TOEFL score. This is what? University rating. This is what? Statement of purpose. This 5 is what? Letter of recommendation. This 10 is what? CGPA. And 1 is nothing but what? Research done. Right? So what is the chance of admission of that student? 92%. Okay, so this is how we create a model with the help of linear regression. Now let me show you what we generally do in real time. What type of output generally we see in real time. Let me show you that. For that, I'll be using one ID, and that is nothing but. Let me show it to you here. I will be using PyCharm here. So whatever the model which we have created just now, right? Let me show it to you. So where we created some web pages, and as a user you can go and you can actually provide the input to this particular model, right? So I'm just opening all these files in PyCharm ID. PyCharm is the ID which is available for running the Python programs or Python projects, we can say, or Python or models, machine learning models, I can say. Now see, meanwhile it opens, let me show you which are the files which I am going to make use of to run complete model. So whatever we have done earlier, with the help of which we got finalize underscore model dot pickle file. Now where are we going to make use of that file in real time? Let me just try to show you that. It is just loading PyCharm. Maybe it will take 1 or 2 minutes. So let me just minimize this. Everything is yeah. Now whatever the code you are able to see, it's a simple Python code. As I told you that I will be sharing those notes and this code also. Whatever the steps I'm going to show you here, same thing you can also apply once you get the recordings for this session. Definitely, you people, if you are interested and if you want to run this particular model, you can go and you can run with the help of following code. See, what I have done is I have created a folder. Inside that folder, I have put all these files. All these files. This file is what finalize underscore model dot pickle. This is the file which we got from Jupyter, right? How we created with the help of pickle. That's what I am using here. And whatever you are able to see, this app.py is a Python program, and static and templates. These are some of the standard folders which we generally make use of. What will happen because of that? Let me show you. See, now whatever you are able to see here, this is PyCharm ID. Let me go and let me open this app.py file, which is actually a Python program. Okay, which is my main program, which is my starting point, I can say. So what I will do is I will go and whatever the model which we have trained earlier, that model I am going to make use of here. I will try to show you what type of a GUI you will get, graphical user interface you will get, and how are you going to enter the input as a user, and how are you going to see the output. That is prediction of a chance of a prediction of that particular student, chance of admission of that student for apps. Let me just double click on this. Yeah, it is loading actually. You can see it is scanning files to index. So whatever you are able to see here on the screen, this is nothing but PyCharm ID. And let me open this code. App.py. So you might be knowing that py.py is nothing but Python program action. Okay, let me double click on this. Now see, whatever you are able to see, it's a Python. Now, what am I going to do is, first and the foremost thing, always remember, whenever you want to run any model, what you need to do is, you need to create something called as environment. Okay, so always remember, you need to create an environment. So whatever the nodes you people will be getting, in that I have given those people who are not aware about how to create the environment or how to run any model, any project in PyCharm IDE, all those tips are already given in those notes, whatever I'll be sharing. Okay, I'll be sharing it with madam. Whosoever is interested, definitely you can go and you can try out all those things. Okay, now see, first and the foremost thing, one needs to create the environment. So in my case, environment is already created. How to check it? So you need to create, you need to click on terminal. So as and when I clicked on terminal, in the console window, I am able to see this particular thing. So this is the name of the environment which I have created. This can be your name. Okay, that is the first step you need to do. Now I will directly go and run the project. Okay. So you will be able to make the sense if you people have understood at least the problem statement. If you understood, you will be able to make sense. What is this? Now what's going to happen? As I run it, it is going to show me a link. See, this is the link I am able to see here. Okay. Now what I will do? I will copy this link and I will just try to hit that link in the browser. And enter. Now see, this is our project ready. Okay, now see, GRE score is out of what? 320. Suppose someone has got 312 marks. Sorry, 312. Profile score is out of, right? Profile score is out of 120. Suppose someone has got maybe 105 marks. University rating is out of 5. Suppose 4. SOP suppose 4. Letter of recommendation suppose 5. CGPA is on the scale of 10. Suppose someone has it. Whether the research done or not. Yes or no. Suppose yes. And now click on this predict. So as and when I click on predict, it should show me what is the chance of the admission of that student to get the admission in the foreign university. So how it is going to be able to do that? Because we already trained the model. And whatever I have shown you, I just combine everything in one folder and I show you to see your chance of for admission is 7%. So actually it's 70%. I just need to go and just multiply it 10 into 4. Okay, chance for admission is actually 70%. See, this is how we also do the same thing in real-time projects. So I hope you people are able to make sense, right? So see, you just enter the value and you got the output. This is the model which we created with the help of a simple algorithm, that is linear regression. I know that I did not discuss theory part of that because I also had some time limitations, but yes. But try to understand this particular model is currently running on my local machine. I did not discuss anything about cloud deployment. So let me first of all confirm from madam itself whether we have some 10-15 minutes. If we have 10-15 minutes, I will show you how to deploy this particular model onto cloud. Let me just
okay, sir. Sure, sure. You can continue.
Okay. So now what I will do is I will show you the steps how to deploy the same model onto cloud so that you people will also be able to make use of my model. Okay, let me show it to you how you will be able to make use of the model once I deploy it. So as I told you, there are some 6 to 7 steps. What one needs to do is, first of all, see, whenever we talk about deployment, there are different options available, right? So there are different clouds you might have heard about. So you might have heard about Amazon Web Services. So there is something called as Microsoft's Azure cloud is there. There is something called as Google Cloud Platform. Then there is something called as Cloud Foundry, or it is called as Pivotal, and there is something called as Heroku Cloud. Okay, so yes, all of them they are free, but for AWS, Azure, GCP, and Pivotal, you need to give your credit card details, right? And many times what happens, we never many people did not use credit card. Some problem is there, right? Again, they are free for 1 year, right? This Heroku is free for 2 years. On Heroku, you can deploy 5 applications at a time for 2 years. At a time, I am saying, okay? And for the here, you can deploy only one application. So what I will do is I'll show you deployment of the same model on Heroku Cloud. Because it is free, creating the Heroku account, it will just take 2 minutes. Okay, I could have shown it on AWS also, but because of this particular thing, I'm just trying to make use of this so that you people will also be able to make use of Heroku Cloud, which is free. It will just take 2 to 3 minutes to create your Heroku account. So in my case, I already created the Heroku account. If you do not have Heroku account, don't worry, it is really easy. Okay, it will not take that much of time. That's what we need. Now, what is the step? What is the next step to deploy your model? So, whatever the files and folders you are able to see here, see, you will be getting all these files. Okay, what I'll be doing is I'll be sending all these files as a zip folder to you. What you need to do is you just need to unzip it. Okay, and once you unzip it, you will be able to see all these things in this folder. So, in whatever the folder your app.py file resides, your main file resides, in whatever the folder it resides, in that folder copy the path. Okay, so I am copying the path here. Now go to command prompt. I am at the command prompt. CD command you might be knowing. So go to CD and just paste that path. Okay, and enter. That means you should be in that particular path where your app.py file actually resides. Okay. Now once you are in that path, now the actual deployment starts. The first step to deploy your model onto Heroku is login to Heroku. So for that command is Heroku login. Even you can go and you can note down all these commands if you want. So Heroku login, enter. It will just take me to the browser. Okay, it will ask me to press enter button once again, and it will take me to the browser where it is just going to ask me to see. I will press enter once again, and it will just take me to the browser, and it will ask me to click on login button. Once I click on login, again I will see here. I will click on login. It should show me logged in. Once I clicked on it, now I will go to command prompt once again. Now see, it is showing me that I am logged in as Yogesh PM5555. This is my personal email ID because I created the Heroku account with the help of this account. So I am logged in Heroku. After this, once you are logged in Heroku, next step is give some name to your application. Heroku create. Suppose maybe I will create an account with MLDS maybe 789. Okay, MLDS 789. This is the name of my application. If that name is available, it is going to create application with that name. Otherwise, it will show me error. So yes, it has shown me that that is available. It is showing me done. That's the second step. Third step is, see, what's going to happen is whatever the files and folders, all these files, right? So all these files are going to be required to deploy your model onto cloud. So what are we going to do is, right now our model is running on my local host, that is my local machine, that's on my laptop. Now as I want to deploy it onto cloud, first of all from the local host I am going to put everything onto Git. Git is nothing but what you might be knowing, Git repository. It's like a storage. So from the Git, then you can go and you can push it onto the cloud, right? And that's why what am I going to make use is I am going to make use of Git repository. Many of you might be having even many of you might be having account on GitHub. So your cloud, that is Heroku cloud, also has a Git repository, and otherwise you can make use of GitHub also, right? So what I'm going to do is third step, I'm just going to initialize the Git repository. So git init is the command to initialize the Git repository. Once it is initialized, if you want to go and if you want to check the status, you can check it with git status. Okay. Once that is done, now whatever the files which are there in the current directory, I want to add all those files onto git. So git space add space dot. Single dot means what? Single dot means current directory. That means whatever is there in the current directory, add all those things onto git repository. This is the meaning of this command, git space add space dot. So go here and press enter. Okay, so if it is not showing you any error, that means you are on the right path. Now, moving forward, once we have done, we have added everything. Now, whatever we have added, let me just commit that. So, git space commit space -am and give any string here. Suppose hello, whatever name you want to write. Hello is just a string. So, this is the command to commit whatever we have done till now. Okay. So let me go here and let me press enter. So everything is okay. Now last step is push your model onto cloud. So for that the command is git push Heroku master. Okay, this is the last command. If it shows error, let's see. Otherwise, if everything is okay. Okay, so it is saying that everything is up to date. So actually it should have shown me the deployment. So what I will do is I will tell it what is the name of my application. So Heroku git colon remote. This command is going to do what? This command is going to tell Heroku Cloud what is the name of the application. So Heroku git colon remote hyphen a. What was the name of our application? MLDS 789. If you people remember, this is the name which I used for my application, and then press enter. So this command is just going to tell Heroku Cloud that okay, this is the name of the application. Set the git repository to that application. Okay, and then once again try to push git push Heroku master and press enter. Let's see. Now it has started the deployment. So see, it is just try to observe. It is detected Python app. It has detected the Python app. It is installing SQLite 3. SQLite 3 is a lightweight database. Okay, that's what our application is making use of. It's going to store the data for temporary purpose, and then it is going to just delete everything. So it's a lightweight database. And whatever the packages which we require for this particular module, for this particular project, all those packages it is installing. How our this particular cloud actually comes to know about all the packages? Because we have given that information in one file, and that is called as requirements.txt file. I will show you that file. Whatever is required for this particular model, everything is given in this particular file, requirements.txt file. Okay, so maybe once this is deployed, I will show you that particular file in which we mention names of all the packages which we require to deploy our model. Now see, everything is done. It is showing what is the size of my application. So it is 101.9 MB. Let me go and try to copy. So see, if you people are able to see this particular link, this is the link with the help of which I can go and I can actually access the application. So I'll copy it. Now what I will do, I will send this particular link to everyone. Just let me know if you people are also able to access my application or not. Just check in the chat box, okay, and just click on the link and just let me know yes or no whether you people are also able to see the application or not. Okay, I hope you should be able to see that. Yeah, I am getting the replies that yes, people are able to access the application. So you people are able to access my application because now it is deployed onto cloud. If I want to show you how it looks like, so see what I will do is I will go and I will try to show you my Heroku account. Heroku login, just Google like this and click on this. And see again, steps to create the Heroku account are also given. Those who are interested to deploy the application onto cloud, you can actually. Many people have seen that those who are working for the PhD project, they are making use of Heroku clouds, AWS clouds also. Now see, MLDS 789. This is the application which we have deployed just now. So in my case, till now I deployed 4 applications. Heroku allows you to deploy 5 applications, right? So these are the deployment steps. This is how one can go and one can actually deploy. I hope everyone is able to see the application on their machine, right? Okay. So let me check what people are saying. Yeah, yes, guys. I hope everyone is able to see that. Let me see any question. Okay. Aisha Hina madam is asking, sir, for biomedical classification or processing, results in GUI are preferred or individual image and results of processing is enough. Results of processing is enough for that, Aisha madam. I hope it's clear. GUI is not that much important, just a fancy thing. Okay. So I think yeah, we are already done with the time. Madam, are you there? So,
Yes, sir.
yes. Now I think if we have questions, if we have time, they can.
Yes, sir. Thank you, sir.
Any question from the participants?
Yes. If any question, let me just. I can unmute you, no problem. Or let me just know in the chat box if anyone any question. Let me just know in the chat box. Okay, Pratik, Pratik sir is asking, why did we create the pickle file, sir? Okay, sir, we created the pickle file because we wanted to create a model which can be used in real time. Pickle file is like a executable file which you can make use of in other models also. For example, this model we created. Now you can say that this model is actually a small part of a bigger project, right? If you are going to need same thing again and again, why to write down the separate code for the same thing again and again? Instead of that, just go and create the pickle file. That's why we created the pickle file, so that we should be able to make use of that particular model anywhere we want. I hope it's clear. Do we get the code of the model? Yes. I will be sharing the code with the madam. You will get that code. No problem. Pramod sir. Okay. Devashri M. Can local machine cluster okay, usage be called as a cloud deployment? No. Local machine, Devashri madam, it cannot be called as a cloud deployment. Because cloud is what? Cloud is nothing but at whatever the location you may be in the world, you should be able to access that particular application, right? So it will not be a cloud. Local host is nothing but, so for example, in my case, first of all, I showed you on my local machine. So it's a local machine, it's not a cloud. WhatsApp is on cloud. That's why everyone is able to make use of WhatsApp at whatever may be the location, irrespective of your location. You can make use of the data which is available on the WhatsApp, right? I hope it's clear, Devashri madam. Okay. Yeah. Amit sir is asking how to deploy a Python notebook code in Bureau Cloud. Okay. So notebook generally we make use of for pre-processing or cleaning of the data. Whenever we want to deploy a model, sir, what we do is we use IDEs. That's why I showed you PyCharm IDE. I hope it's clear. That's why in real time, what we do is in real time we make use of notebooks for pre-processing. Is it clear, Amit sir? Yeah. Okay. Yes. Any other doubt? See, we had some time limitation. That's why I could not discuss some of the points actually which I didn't discuss. But no problem. I hope you people will just try to go through the notes which I'll be sharing. If you are really interested, definitely we'll be there. Okay. Chandana Raj sir is asking to unmute. Just a minute, sir. I will unmute. Yes, you can unmute.
Hello, sir.
Okay, madam. Yeah, madam. Yeah.
Sir, where do we get that link to access this?
What are you saying? What do you want to access?
Sir, if you want to continue this, how to access, sir? Yes, sir.
You are saying this session?
Which link, madam?
Oh, hello. Okay, yeah, I already unmuted you. Just let me unmute you once again. Yes, you can unmute, madam.
Sir, if you want to know further how to get that link.
I'm not actually getting what are you asking. Which link you are asking about? The link for this session or what?
Sir, this session continuation, how to know?
No, madam, this session is only for 1 hour. It's a webinar actually.
Okay.
I think if sir doesn't mind, he may give his email ID. If you have any questions with respect to your research work, you can contact him through.
Okay, ma'am.
Yes. If you people have any doubt.
Sir, do you have GitHub account, sir?
Yes, madam. Yes.
If you are.
You can just contact me here.
Okay, sir.
If you need any help, definitely I will be happy to help.
Okay, sir.
And I am on YouTube also. This is my YouTube channel. Even here also you can connect.
Okay, sir.
Okay. Any other doubt?
Okay, if there are no doubts from the audience, so this opportunity to thank Yogesh Murumkar sir for giving a very knowledgeable and more insight on machine learning with the cloud deployment. Thank you very much for sharing your valuable time and sharing your knowledge on this particular topic. And also, I would like to thank all the participants for your participation. Thank you all.
Thank you all.
Thank you, sir. Thank you
madam.
once again.
Thank you, madam.
Thank you very much.
I will end the meeting, madam.
Yes, sir.
Yeah.
So I request, oh, sir, 1 second, sir. I request all the participants to fill the feedback to get the certificate.